800-447-7911. All right, overlooking Manhattan, here is Richard C. Hoagland. Hi, Richard.
Good morning, Art.
Good morning. All right, a lot of territory to cover, Richard. Something has happened on our sun.
Yes, and it's headed our way.
And it's headed our way, huh?
Yes, the bad news is maybe several $1 billion worth of satellites could be damaged or made into useless junk. The good news is there's no danger to human beings or animals or pets or whatever, and there could be a rather spectacular light show in the northern skies when this stuff hits the magnetosphere of the Earth and creates the Aurora Borealis.
Richard? I react more to the bad news. You see, I have about 3 satellite hops that are required to get me from here to there, wherever there is.
Yes.
And if it takes out one of my satellites, it takes out me.
We'll be listening to a lot of dead air.
Yeah, you've got that right. So
you have alternate links?
Well, we've got alternate links that would get us, for example, to New Jersey, to where they uplink to C-band.
Right.
Yes.
Okay.
But if the C-band bird goes, that's it.
All right, let's back up and start at square one. For people who don't know anything about solar physics or hyperdimensional physics or any physics, I'm going to try to make this as painless as possible.
Okay.
The sun is a star. It's almost 1 million miles in diameter, 800 and some thousand miles across. It's very bright, and we are less than 100 million miles from the surface, 93 million miles. All right? We orbit in a period of 1 year. It's roughly a circular orbit. Our orbit varies by a couple of million miles, but basically we go around the sun at the same distance all year long, give or take a couple of percentage points. The sun is not a quiet star. It has activity, both inside and ultimately on the surface. And regardless of what model you look to explain why the sun shines,
yes,
the standard model is that it's a huge contained thermonuclear raging furnace,
right,
like a hydrogen bomb,
right,
and that the gravity holds it together.
It is a fusion reaction,
well,
right?
That's the standard model. It's a fusion reactor. In fact, our data suggests that it could be a lot different than the standard model, but let's go with the standard model for a minute, all right?
All right.
In this standard model, the sun has been consuming hydrogen for billions of years, 5 billion plus years, which is a long time. That's 5 billion orbits of this planet we live on.
Right.
1 year being one orbit, all right?
Okay.
It will last for at least another 5 billion years, okay? So this is a very natural, normal thing in the immense, enormous history of this star that we are tethered to called the sun, on which all our life is totally, and I mean totally, dependent. In the last 50 years, astronomers, of which I count myself one, because that's my background. This is really kind of, old home for me, because I eat this stuff up, and that's how I got into this field.
Sure.
I was at the Hayden Planetarium, I was at the Jenger Science Center, I was at the Springfield Museum of Science. This is what I used to do before I got into aliens and ruins and ET artifacts and all that stuff.
Right.
The sun is not a constant star. It is what would be technically termed a variable star, meaning that its output goes up and down by a little bit.
Okay.
Now, it was several hundred years ago when this was first noticed, shortly after Galileo discovered there were sunspots. Other astronomers coming after him noticed that there were sunspot activity which was quasi-regular, that the sun was not blemish-free as the church had been teaching, but in fact there were spots in heaven. There were spots on the sun, and you could actually use them to measure how fast the sun rotated. The spots at the equator go around in about 27 days. The spots at about 30 or 40 degrees latitude, north and south, go around in a much slower period, relatively speaking.
Makes sense. Sure.
Around 30 days.
Sure.
33 days. So the sun, right away, from looking at these ancient observations, hundreds of years old, turned out not to be a solid structure, because obviously a solid structure could not twist so that the poles were going around slower than the equator. We were looking, it turned out, from these observations with early telescopes at a gaseous surface. Now we know that gaseous surface, which is 500,000 miles from the center, at about 6,000 degrees centigrade, or roughly 11,000 degrees Fahrenheit, is basically what transmits the energy across space to us, created in the center of the sun by unknown reactions, presumably fusion in the mainstream model, and in a more interesting fashion in our own model, all right? These spots that we see on the surface that astronomers have been looking at now for hundreds and hundreds of years, then about 200 or 300 years after the telescope was invented, someone realized that they were regular, that they came and went in a period. They appeared to come and go in a period of about 11 or 12 years.
The solar cycle.
The so-called solar cycle.
Right.
The spottedness increases, comes to a peak, and then fades away. And you can actually draw almost a sine curve where the curve goes up and down in a very regular fashion, except it isn't absolutely regular, and that's the detail we don't need to get into tonight. Then, in the early 1900s, when people like Hale established observatories out west, the Palomar Observatory, Mount Wilson Observatory,
right,
whatever, they invented devices to actually measure the magnetic fields of the sun by remote sensing. And Hale discovered that the sunspots waxed and waned, grew and receded in frequency in the same period as the magnetic field of the sun changed, except it was half the period. So the full period is not 11 years, it's 22 years.
Right.
So that's now what's called the total sunspot cycle. Half cycle is 11 years, the full cycle is 22 years for the sun to reverse polarity and go back to the same magnetic field polarity as it was 2 sunspot cycles earlier.
And we are either at the low point or just coming out of the low point.
We're just coming out of the low point in this 11-year wax and wane spottedness cycle.
Right.
Now, the spots, it turned out, were not the really important thing. They were an indicator of much more intrinsic and deep-seated solar variability. And when we got satellites up, beginning with Skylab and SolarMax and a bunch of others, I mean, the space program has really been doing some important, neat stuff. It's contributed to our knowledge, our database, and our economic well-being. It was discovered that, in fact, the so-called solar constant, which is a fiction in astrophysics, it now turns out, astronomers, in the last few hundred years were measuring the amount of light and heat coming from the sun.
Right.
And they thought that it was constant, year after year, day after day, week after week, century after century. It turns out now, from very accurate measurements conducted in space above the atmosphere, which really kind of screws up delicate observations, that the solar constant is no more constant than a lot of other things we used to think were constant. And in fact, it waxes and wanes with a total variability of about 0.1%. Now, that doesn't sound like much, but if you compare the solar output, I mean, you realize how bright it is out in the desert there in Nevada, right?
Oh, yes.
All right. The solar output on Earth measures roughly 1 kilowatt per square meter, if my memory serves me correctly. That's light, heat, ultraviolet, everything, all right? If you multiply that 1 kilowatt per square meter at the Earth's distance by the total number of square meters in a sphere englobing the sun at the distance of the Earth from the sun.
Yes.
Imagine a huge sphere, 93 million miles in radius.
Right.
And the number of square meters or square feet or square miles in that incredibly enormous sphere, right?
Yes.
Well, the sun is pumping out energy so that each square meter of that sphere is getting 1 kilowatt, roughly, per second. One joule per second.
Okay.
1 kW.
Right.
That's a staggering amount of energy.
Yes.
Incredible amount of energy.
All right.
Well, 0.1% of that is variable. That's an enormous variability. It's like having a bank account. If you say that your bank account varies by 0.1%, it doesn't mean anything. But let's say you have an annual income of $1 trillion. 0.1% is one hell of a variability, right?
Yes.
Okay. So that small variability on the sun scale of the sun can have enormous effects on the scale of life on Earth.
Okay.
That's why everybody's looking at this solar variability.
All right. Explain to us, there is I don't understand something myself, and I follow this whole thing. When I heard this afternoon, I ran to WWV and listened, and there was nothing abnormal at all. And I said, come on, Richard, what's going on? And you played a 6-minute John Holloman piece from CNN on this whole thing for me.
Yep.
And I went, holy mackerel. Now, I know what sun flares are.
Yes.
And I couldn't find any indication on WWV, the National Bureau of Standards, that the numbers were changing. And yet they're saying this massive thing is coming our way. And so I understand what a flare and then a consequent storm is.
Yep.
I don't understand, Richard, the difference between a solar flare and what they're calling a solar plasma ejection.
Mm-hmm.
What is the difference?
Scale. Size.
Size.
In other words, the sun is hiccuping, but on a scale bigger, much bigger than it normally does.
As in firecracker compared to bomb.
Yeah, exactly. All right? And the effects, you know, let me describe the physics of what's going to happen. 4 days ago, Sunday, at 18:22 Greenwich Mean Time, which is 6:22 in the evening in London, on Sunday evening, London time.
Right.
On the lower right-hand section of the sun's surface, at 19.5 degrees.
Of course.
Well, it has to be, all right? But we'll get to that in a minute. Something huge happened. An explosion, a titanic, gargantuan explosion occurred on the surface of the sun and ejected at thousands of miles per second a huge blob of electrified hydrogen gas and electrons called a plasma. This stuff is so hot that it isn't normal matter. In other words, it's not the electrons and protons, the nuclei and the electrons are not coupled to each other. They are together but separate, like a huge mixer of divorced couples.
Electronic anarchy.
Exactly. And that huge blob of very hot stuff is racing upward from the sun.
Now, it is my understanding the sun could aim this, depending on where the sun was turning at the time, in any direction. However, in this particular case, folks, this blob, solar plasma ejection, is headed...
Movies we have known.
Is headed, blob, straight at Earth.
No, it's not.
No?
No, it's not. No. If you were above the solar system, in a spaceship, hovering above the north pole of the sun, which is almost the north pole of the solar system because the sun is only tilted by 7 degrees as a rotating sphere of gas to the plane of the median orbits of all the planets, you would see the sun rotating majestically every 27 plus a number of odd days, or 27 point something days. That's at the equator. If the sun ejects something near the equator, 19.5 degrees is pretty near the equator.
Right.
Because it's rotating, the blob of stuff does not fly straight out. It flies in a curved arc, like the water droplets from a spinning water thingy on the...
Or like when a golfer putts on a little hill, he sends it up on a little curve to the hole.
Right, but a water sprinkler is a better analogy.
All right.
If you've ever looked at a rotating water sprinkler, the droplets come out and they make a beautiful Archimedean spiral.
All right, well...
So what's happening is this material is making an extraordinary arc in space. And 4 days after it was ejected, that arc is going to stretch across the Earth's orbit. We're at the right place in the orbit to come along and plow through it.
All right, so metaphorically, I was correct.
Yeah, but it's not, there are no such things.
When I said it's coming straight at us, I should have just said it's going to hit us.
It's a curving arc, and we hit it, and it hits us.
All right.
At thousands of miles per second.
All right, and when that occurs?
When that occurs, because it's an electrified blob, all right, it's very rarefied. I mean, if you were in space and put your gloved hand out, you wouldn't feel a thing. But electrically, if you were sensitive to electrical currents, electrical fields, if you were a conducting body,
right,
like a spinning metallic spacecraft,
right,
with highly sensitive solid-state chips and components and spinning gyros, in other words, a quivering bundle of finely tuned high-tech hardware.
Something like a satellite, say.
Like a satellite, yes. This stuff is bad news, because what it does is it charges up the surface of the satellite. The satellite rotating creates magnetic fields, and depending upon the strength of the material, how long it takes to go past the Earth, the blob is, of course, not a point, it's a blob. It takes some time for it to move past the Earth.
Well,
it will cause all kinds of havoc with finely tuned satellite hardware in space.
Telstar 401 was lost, along with, I guess, a couple of military satellites, with a more minor occurrence than this, not long ago. I guess it's anybody's guess, Richard. It could either come and be relatively harmless, or it could be very harmful to satellites.
I think the folks in the know exactly how harmful, and they're not telling us, and that is bad news. That tells me that they're not being candid, and the fact that WWV, 4 days after this event, is not saying a damn thing about it, indicates your government is not playing straight with you. If you wanted a more definitive example of how folks, when they get news they don't think we can handle, don't tell us the truth, that's a quintessence example.
It absolutely was amazing. I mean, at 18 past the hour, they forecast 24 hours ahead, and it's my understanding this is due to hit tomorrow, right?
That's right. But when I was in radio,
not a word about it.
Art, when I was in radio, I used to do radio when I was in the museum many moons ago. The station manager came down to me one day, and I was reading the weather, and he took me aside and he says, "Dick, psst, Dick." I said, "What?" He says, "No, it's not partly cloudy, it's partly sunny." And the reason was the spin. Partly sunny, people go out and shop. Partly cloudy, they stay home. So I learned very early on that weather, including interplanetary weather, can have a drastic economic effect on people.
What was his advice to you?
Rosy.
Yeah, I understand. What was his advice to you when it was going to be either cloudy or raining that day?
Well, then we had to tell the truth. But the partly business was interesting. We could shade it, pun intended.
At the margins, yeah.
Yes, at the margins. So, all right, the fact that they're not saying anything, the fact that John Holloman actually got on and said, "We thought you ought to know," I thought was very telling.
Oh, it was a very serious report.
NASA is scrambling to put together a press conference for sometime tomorrow, so you know that they're wanting to get on the side of the angels and say, "Oh, we were up front."
NASA will have a press conference tomorrow.
Sometime tomorrow. We don't know the time yet.
All right. Richard, hold tight. We'll get right back to you. Richard C. Hoagland is my guest, and this comes under the category of I Thought You Should Know. A huge solar plasma ejection has occurred. This may also mean the northern lights are going to come south. We'll talk a little bit about that and more in a moment. I'm Art Bell. This is CBZ. Now to Richard C. Hoagland. And Richard, you're the science end of it, but I must tell you, a lot of people are faxing. I had Father Malachi Martin on. He said, watch the sky for an event. Now, that's a Catholic priest with a metaphysical sort of a word to us, but it kind of fits in. What might happen regarding the northern lights coming south?
Well, look, there's nothing mumbo-jumbo or mystical about this. In terms of the physics that we all know, we know exactly what's going to happen. You have a huge blob of electrified stuff, which is damaging to sensitive electrical equipment. And what it's going to do, it's going to hit the Earth's magnetosphere. Now, the Earth has a magnetic field. It's like a dipole magnet. It's got a north and a south pole.
Right.
And this dipole magnetic field acts as a shield. It's kind of like the Enterprise putting up its shields. They're there all the time.
Okay.
Back when Van Allen put up the first measurement gadget on Explorer 1 back in 1958 in January, our first satellite in Earth orbit, back when NASA was just an infant,
right, we
found that the Earth is surrounded by radiation belts. Those radiation belts are the product of the trapping and screening and deflection process of the Earth's normal magnetic field from this kind of normal solar activity, which is happening all the time. If you look at a solar eclipse...
Is the ozone any part of that deflection?
Well, the ozone is for the electromagnetic, the visible radiation or the invisible radiation part. This is not electromagnetic radiation that's coming toward us. It's moving much slower than the speed of light. It's only moving at a few thousand miles per second. All right? It's protons. It's actual solid matter. It's, it's electrified bits of subatomic stuff.
Okay.
It's not gamma rays, it's not X-rays, it's not light waves, it's not infrared, which would get here in 8 minutes at the speed of light.
All right, what will cause the northern lights to increase?
Okay, what happens is when this electrified stuff interacts with the Earth's magnetic field, a lot of these protons and electrons will be scooped up by the field and trapped into orbit around the Earth, gyrating in the magnetic field of the Earth as it's supposed to happen. The problem is that the Earth's magnetic field is already loaded with electrified particles in the so-called Van Allen belts, donut-shaped belts, that are the result of loading up the Earth's magnetic field from the normal solar activity.
Right.
Normally, coming out from the sun, there is a thing called the solar wind,
right,
which moves at about 500 miles per second. It's an extremely thin, I mean, we're talking super, 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 super thin stuff that you couldn't detect except with an incredibly sensitive instrument, all right?
Yeah, but I've heard that spacecraft could be propelled by it.
No, that's light pressure. That is actual photon pressure from the light of the sun.
Not solar
sails,
wind,
stuff like that, all right?
Yeah, right.
The solar wind is what's causing the blue ion tail to stream out behind Hale-Bopp. It's the interaction with the literal electrified atmosphere of the sun moving outward at in excess of escape velocity, which you can see near the sun during a solar eclipse as that pearly glow around the sun.
Okay.
Those are electrons in the solar wind, in the million-degree-plus atmosphere of the sun, escaping a very dilute, extremely thin atmosphere, evaporating off the sun constantly.
So suddenly we're going to get a big charge.
There's a huge blob of this stuff. Think of it as a kind of a storm in an atmosphere. That's a good metaphor.
Okay.
And this storm is going to cross space right when we cross space, so there will be effects. Now, what happens is when it strikes the Earth's magnetic field, it causes the particles in the field that are trapped upstairs to be dislodged. They have to go somewhere. Some of them come down the field lines and dump into the planet at the north and south magnetic poles. When they are zipping down the field lines, they interact with the Earth's atmosphere. There's an atmosphere in the way. If we didn't have an atmosphere, you wouldn't see anything. Of course, we wouldn't be here to see it anyway. But because there is an atmosphere, in a beautiful oval around both magnetic poles, and because there's nobody around the south magnetic pole, most of civilization lives in the northern hemisphere, we think of the Aurora Borealis. There's also a simultaneous Aurora Australis, the southern lights, all right? All this is, and it was a guy named Sturmer, who was one of my dim ancestors in Sweden many decades ago, who first put the physics of this together in scientific papers. The electrified interaction between the Earth's atmosphere and these highly charged particles zipping down the field lines, basically bumped out of their stable configuration by the impact with this blob of electrified stuff coming from the sun, causes the belts to dump out to a percentage. And the dumping out occurs at the northern and southern magnetic poles, so if you live near the poles, if you're an Eskimo, it looks incredible. It doesn't reach the ground. It completely dissipates in the upper atmosphere, but it creates huge vertical curtains of incredible colors and shifting
shimmering. I know, I've seen it. I lived in Alaska, and we've got listeners all over Alaska, so they're probably in for a pretty good treat, huh?
Our harp watchers up there are going to have one heck of a treat. Now,
but the question is, how about, before we get to the shuttle, how far south might it come? That's what they were talking about.
Depending upon the intensity, and this goes back to, are they leveling? I don't think they're leveling, otherwise they would be telling us exactly what the effects would be. I'm expecting we're going to see some pretty amazing things here in New York, which is, as you know, 41 degrees north latitude.
Right, okay.
They were claiming conservatively, the astrophysicist that John was talking to on CNN this afternoon said Boston. I'm thinking New York. I'm thinking, 40, 45, 40 degrees around across the country. So a good swath of the country can see something interesting tomorrow night if it's clear, I would think.
So it's going to be an interesting event, and you wouldn't necessarily out here in the desert sunbathe tomorrow.
Well, there's no problem with the light. Remember, the light got here in 8 minutes. The flare occurred Sunday afternoon. Whatever you were doing outside out on Sunday afternoon, you've already gotten your dose.
Damn. All right.
Whatever you were doing, we don't want to know.
I see. All right. Now, the shuttle. The shuttle, of course, has come home early, ostensibly due to a fuel cell degeneration failure.
I'm extremely suspicious.
You don't think that's a reason, huh?
No, and here's my logic for this, and now this is going to, move away from the mainstream into the model that we've been working on for 15 years, and the physics and the hyperdimensional model. I have got up on the portable computer here a copy of Redshift 2, which I went out and got a few days ago, which is the upgrade to the computer program that I've been talking about.
Yes.
From Maris Multimedia.
Yes, sir.
I've got the sun enlarged filling my computer screen for 8:22 GMT on the 6th of April, a few days ago, all right?
Yes.
And I'm comparing the computer projection of the poles and the lat longs on the sun
yes.
with the photographs that I can still frame on the video from John Holloman a few hours ago
yes.
on my big TV screen, side by side.
Right.
And of course, this thing is ejected at 19.5 degrees south latitude. Now, why is that important? Because in our model, as opposed to the standard model, the energy of the sun is primarily coming from hyperdimensional physics processes, not from fusion.
Right.
And I have said on your show over and over again that the physics is changing. Like the variability on the sun, it goes up and down in a long period of time.
Okay, but no matter which model, what effect would that have on the shuttle?
Well, here's what things get really interesting. In the standard model, it would be impossible to really predict accurately when one of these flares was going to occur. But in the hyperdimensional model,
you can predict it.
Well, there have been people already predicting it in the open literature, which I can refer you to, or better yet, I'll put it on our website, www.enterprisemission.com, or you can go to Art Bell, and there's a link from his site to our site.
Right.
There was an engineer hired 50 years ago by the RCA Communications Corporation. RCA, remember them? NBC?
Oh, of course, the dog and the horn.
Yep. And basically he was hired to allow them, RCA, to successfully transmit low-frequency radio waves, called shortwave radio, paradoxically.
Right.
And to send messages around the Earth.
Right.
In the 1920s and 30s.
Right. I'm a ham. I'm shortwave all the time. This will crush the shortwave band.
For a while, yes. Yeah. Well, the problem with RCA was that they were charging people to send radio messages and traffic and telegrams, and they couldn't charge them, their customers, if they couldn't get the message through.
Right.
So they hired this engineer, whose name escapes me at the moment, John Nelson, that was his name, all right? And they said, basically, John, do something. We need to have a predictability to this. We need to know when the sun is going to do whatever it does and screws us up.
Yeah. And
we don't want you to come up with why it's doing what it's doing. Well, lo and behold, John Nelson worked for several years, and he developed an astrological model for solar activity, sunspot activity, flare activity, interference with shortwave radio. And it was based on the geometry, this beginning to sound familiar, of the motions of the planets around the sun. And it was John Nelson's data, which we factored in now to our own model, which is exquisitely predictive, which demonstrates overwhelmingly that the solar activity, for inexplicable reasons from the mainstream crowd, is dependent on where the planets are in orbit around the sun.
So, in other words,
big guys especially.
It enhances your hyperdimensional model.
Well, because it's the fleas wagging the dog.
Yeah. All right. Speaking of fleas
now,
and dogs,
let me get to why NASA, is not telling us the truth about this.
Please.
NASA's got this model. They have refined Nelson's model. Some folks deep inside know about the physics and are using it in the space program. They're just not telling you. All right. They somehow got wind of, in their computer models, that a big, huge event was going to happen on the sun before it happened, on Saturday. And they had to come up with a cover story. And now they can't say, oh, look, boys, we've been able to predict the sun based on hyperdimensional physics, because if they did that, a whole bunch of other stuff would fall out of the closet, not the least of which is free energy. We couldn't have that now.
No, couldn't have that.
So they have to come up with an excuse. So they came up with this fuel cell. I mean, give me a break. They really think we're dumb. If there was a fuel cell problem, mission rules say you come home right away. They waited from Saturday until Tuesday.
They did. It's true.
The reason is they know this thing's not going to hit till tomorrow, and they wanted to get as much experiment time in as they could, and they went to the hype of having TV.
Yeah, but Richard, they were claiming that there was a slow erosion in the fuel cell, and if it reached X number of millivolts...
Well, of course they were claiming that.
Yeah.
That's what they had to do with the cover story.
All right, so here's an obvious question then.
Now again, I don't have this as absolute data. This is my projection based on the fact that they didn't come home immediately.
But if it's bad for the shuttle, then why is it okay for Mir?
Because Mir has shielding. The shuttle is meant to be a bus.
I'm going to give you some news you didn't know.
Okay.
I have a lot of hands. In fact, I talked to Mir a couple of weeks ago. We talked to Mir.
Yes.
The cosmonauts on Mir.
They have a storm cellar in Mir.
We have not been able to be in communication with Mir for 4 days.
Okay.
I don't know what that means. I'm just telling you it's true.
Well, it means they're probably very busy. You know, they've had some internal housekeeping problems.
I know.
They're probably not talking to anybody. But the Progress rocket docked successfully this afternoon. They've got enough lithium hydroxide canisters to last them for, a couple of months now. And the reason they're not coming home is because it would be more dangerous to bring them home in that little Soyuz that's attached as a lifeboat.
Yes.
Than it is to just have them ride it out. Remember, they're deep under the Earth's magnetic field.
You said they've got a solar cellar, or something.
They have what's called a storm cellar.
Okay.
And it's basically a protected part of the center of the ship, of the space station, surrounded by water tanks and other stuff which absorb protons and electrons.
Oh, I was going to say like the thing that the dentist puts in your lap when he takes pictures of your teeth.
Well, no, part of it is metal, part of it's lead, but most of it is basically consumables and water. Water is an excellent absorber of this kind of particle radiation.
All right, so anyway, it'll be interesting to watch the sun. You've got suspicions about why the shuttle is here, and now I would like to say congratulations on making Time magazine.
Well, as Mark Twain used to say about being ridden out of town on a rail after being tarred and feathered, if it weren't for the honor of the thing, I'd just as soon pass it up. Tell them what we're talking about.
All right. In an article which I've been telling my audience about, entitled The Man Who Started the Myth, Time magazine wrote about me, wrote about my show. You know, it's a connection they tried to make to the suicides in Rancho Santa Fe. And interestingly, as they wrote about me in their style, it says, other remarkable Bell shows, I'm reading from the Time article, have involved such subjects as a 57 Chevy that just fell out of the sky in Long Beach, true, a farmer who threw machinery and dead cows into a hole on his property and claimed that they never hit bottom, true, and an interview with Richard Hoagland, who claims the government is suppressing news of alien structures on the moon and Mars. Now, I did the interview with a guy from Time. Your name never came up, and yet you showed up in the article.
Isn't that interesting? I almost feel like church lady. Isn't that interesting? Leon Jeroff has had it out for this investigation from the beginning. When I was, many years ago when we started this, I took Dr. David Webb, who was a member of President Reagan's Space Advisory Council, to New York to meet with Walter Cronkite, to brief him, his first briefing in person by me on the Mars investigation. Mm-hmm. And that same afternoon, we went across the street to Time magazine to sit down with Leon Jeroff, their science editor, mm-hmm. and to brief him on our investigation. Jeroff subsequently wrote the most incredible hit piece on me in Time magazine. This is like 10 years ago, something like that. Mm-hmm. That's when I knew that the deck was stacked, when it was not an honest, level playing field, that somebody had it in for even asking the wrong questions.
Well, Richard, I've learned something over the past 2 or 3 weeks, and it is that the American media, the large media, the networks, Time, the major newspapers, LA Times, New York Times, they have a story the way they want to tell it, and be damned the facts. The facts don't really matter. If they want to put a certain spin on a story, they simply, absolutely, without question, do it. I just watched it happen.
Go on and read the next sentence right after where you concluded, all right?
Let's see, move more. Bell brushes off critics who charge that his uncritical airing of such nonsense only promotes scientific illiteracy, and as in the case of Heaven's Gate, can actually have harmful consequences.
Okay. I believe that we have an actionable item. This is called libel. And in the morning, I just got this fax to me, by the way. It's in the April 14th issue of Time. I'm going to turn this over to our attorneys to see what actions we can take against Jeroff and Time Magazine, because this is libel. This is a very serious scientific investigation. We have NASA sources inside leaking us stunning pictures, data. The new journal is finally out from the printer. Everybody all over the nation, you are going to get your journals in the next week or so. We're literally beginning the process of sending them out tomorrow. I'll send you a couple copies, Art, so you can peruse it.
Okay, but you know, I'm not sure about the actionable part, Richard, because it says can have harmful consequences. If they had said did have,
no,
it would be different.
He is.
They're very careful, Richard.
We are being tarred by association. We are the only person other than Courtney Brown who specifically went out on a limb on the Hale-Bopp thing. Yep. We had nothing to do with spaceships and companions. In fact, I was on your show claiming...
Well, now, to be fair, that did get in the article. Richard, that did get in the article that Courtney Brown was the only one who said there was a spaceship behind Comet Hale, or between the... beyond the comet.
I'm going to investigate what we can do, because the only thing this country respects is legal action anymore. And what will happen if I can bring some kind of suit is that somebody in the mainstream will start paying attention to the data, to the fact that there is a remarkable data that this government is sitting on.
So you would do it to get the, in other words...
No, I would do it because I don't like to be called nonsensical. I'm not nonsensical, and the scientists that are working with us, eight of whom, stood up in front of the world press at the National Press Club 1 year ago, last month, including Sarah McClendon, all right, who I guess you had on your show.
I did have her on. She was wonderful.
Wasn't she? Isn't she incredible? I saw her at today's press conference, and she is 85, I believe, and going strong. Anyway, she thought we were treated shabbily. And unless someone makes an issue of it, and I think to bring us in as the hind leg of the dog, when from day one I was saying, be careful, this comet is not what everyone is claiming is something more interesting. Tom Van Flannen and I did your show to provide another serious model for unusual aspects.
Absolutely. We did all kinds of shows. And so
to bring us in this article on that subject is gratuitous, libelous nonsense.
All right, well...
And Jeroff is going to have to answer for it at some level.
Keep me informed
we will definitely keep
on how that goes. We've got to go. But, Richard, thank you so much for the report. And in the next few days or next week, we'll have you back after this has occurred, and we'll see what happens. We'll talk about it.
Well, the key thing here is it's occurring at 19.5. The physics is unfortunately alive and well and is being confirmed by this. And there is more, so stay tuned.
All right, my friend. Talk to you soon. Richard C. Hoagland from an area near Manhattan. Actually, I think he is in Manhattan, overlooking it anyway. There you are. As for me, I wouldn't sue Mr. Jeroff because I do, on occasion, absolutely nonsensical things, and sometimes very serious things. I simply assume that you are all adult enough out there to understand and separate one from the other. In other words, we're programming, I hope, to rational people. Have you (800-447-7911). All right, overlooking Manhattan, here is Richard C. Hoagland. Hi, Richard.
Good morning, Art.
Good morning. All right, a lot of territory to cover, Richard. Something has happened on our sun.
Yes, and it's headed our way.
And it's headed our way, huh?
Yes, the bad news is maybe several $1 billion worth of satellites could be damaged or made into useless junk. The good news is there's no danger to human beings or animals or pets or whatever, and there could be a rather spectacular light show in the northern skies when this stuff hits the magnetosphere of the Earth and creates the Aurora Borealis.
Richard, I react more to the bad news. You see, I have about 3 satellite hops that are required to get me from here to there, wherever there is.
Yes.
And if it takes out one of my satellites, it takes out me.
We'll be listening to a lot of dead air.
Yeah, you've got that right. So
you have alternate links?
Well, we've got alternate links that would get us, for example, to New Jersey To where they uplink to C-band.
Right.
Yes.
Okay.
But if the C-band bird goes, that's it.
All right, let's back up and start at square one. For people who don't know anything about solar physics or hyperdimensional physics or any physics, I'm going to try to make this as painless as possible.
Okay.
The sun is a star. It's almost 1 million miles in diameter, 800 and some thousand miles across. It's very bright, and we are less than 100 million miles from the surface, 93 million miles. All right? We orbit in a period of 1 year. It's roughly a circular orbit. Our orbit varies by a couple of million miles, but basically we go around the sun at the same distance all year long, give or take a couple of percentage points. The sun is not a quiet star. It has activity, both inside and ultimately on the surface. And regardless of what model you look to explain why the sun shines,
yes,
the standard model is that it's a huge contained thermonuclear raging furnace,
right,
like a hydrogen bomb,
right,
and that the gravity holds it together.
It is a fusion reaction.
Well,
right?
That's the standard model. It's a fusion reactor. In fact, our data suggests that it could be a lot different than the standard model, but let's go with the standard model for a minute, all right?
All right.
In this standard model, the sun has been consuming hydrogen